Welcome back, folks. Looking at the mesh shortcut a little bit more, mesh by inspection, if you will. And we got another one that has a super loop in it. So it's going to have a current supply that has two mesh currents flowing through it. That's how we know it's a super loop. So let's just get to it and see what happens. Because I think these are moving quicker. I hope you're starting to get the feel that you can do this analysis and you can do it quickly. Okay, so we've seen this one before. I'll even move out of the way. And it looks like we have three meshes. I'm going to have to squeeze all this in there because it's a larger problem. And let's see here. So let me grab my pen and let's get to it. Okay, so it's going to be a 3x3. Let's see if I can squeeze it all in this way. I'm going to invert it. And I'm going to multiply it by the right-hand side. It looks like I can't write everything out over here, but I think we can make do. Let's try to make do. Okay, so I have three equations to find my three unknowns. That's what I got to write. One of them is going to be a KCL because I have a current supply. So let's go ahead and start out with the current supply. So we say, does I1 touch the current supply? It does, and it flows in the same direction, so it's positive. Does I2 touch the current supply? It does not, so that's a 0. And does I3 touch the current supply? It does. And does it flow in the same or the opposite direction? It looks like it flows in the opposite direction in this case, so it's negative. Right-hand side is whatever's labeled on the current supply. So here it's labeled 6 amps. It's going to be 6 amps in our system of equations. All right, I've got to write two KVLs, and we did this before, so we kind of know, we worked this exact problem in a few videos ago, and we kind of know what's going on with that. We're going to write a KVL, let's do the hard one first, right? Around the two meshes that run through the current supply, and therefore those are the two meshes that form the super loop, right? We take our two bubbles of meshes, and we make the one big bubble. And we're going to ask ourselves the same questions that we did in the last video, but we got a little bit more going on here. Okay, so what does I1 touch that's on the super loop? So I1 touches R1, and that's 2. So let's see, that's 2. And it's on, I1 is part of the super loop, so it's going to be positive. What does I2 touch that's on the super loop? It looks like I2 flows around here. It touches this 2 and this 4, and those are on the super loop, so we're going to include those. It doesn't touch this one, so we don't include that one. So it's going to be 2 plus 4. It's this 2 plus this 4. So it's going to be 6. Okay, and I2 is not part of the super loop. So it's a shared current, and therefore it's negative. Not too bad. Last one, I3, what does it touch that's on the super loop? It touches the 4, and it touches the 8. So 4 plus 8 is 12. And I3 is part of the super loop, so this one's going to be positive. The right-hand side, we got to look for voltage sources. And it looks like we only have this 6 volt out here, and we're going up 6 volts. So it'll be up 6 volts. All right, not too bad. Takes a little practice. And you'll have plenty of opportunity to practice. I'll make sure of that. Okay, last equation that we had to write, and I did these a little out of order from the last time. I'm looking at my solution up there. You know, the order that you write the equations in doesn't matter. You can swap these rows all you want. But the last one we need to write is the KVL around I2. So what does I2 share with I1? It shares R1. So it's shared, so it's -2. What does I2, well, we're doing the equation for I2, so what does I2 touch, period? Okay, so we've got 2 plus 2 plus 4, and that gives us a grand total of 8. And then what does I2 share with I3? And it only shares R3, so it's -4. And as we move around here, there's no voltage supplies, so the right-hand side is equal to 0. Okay, so I'm going to calculate this. Sorry, I have to do a little line break here. I'm going to calculate this, and this is going to give me I1, I2, I2, and I3. Okay, and that corresponds to the coefficients up here in the columns. And then I'll get those labeled somehow. I'll fit that in there. But let's go ahead and calculate this. I'm going to grab my calculator. Hopefully you've already started doing that. You can always pause the video. Can't do that in the live class. Kind of cool, huh? Looking for the silver lining, folks. Always looking for the silver lining. Okay, so it's a 3 by 3, 1, 0, negative 1, 6, 2, negative 6, 12. Oops. I missed something. 2, negative 6, 12. Oops, 6. There we go. And negative 2, 8. Wow. Fat finger in this one a lot. Negative 2, 8. Negative 4, 0. And we end up with 6.32 amps. I'm just making sure I did my rounding equivalently. Yeah, 1.74 amps they're matching so far. And 3.1, not 3.1, 315.8 milliamps. Okay, so there are our mesh currents. We did that without having to write any equations. We just went right to the matrix form. So if we're taking that and we say this is from a previous problem, just so we know where these magic numbers came from, you have the video on how we wrote this exact matrix, and you can compare the images. They'll be identical. From previous video. It's kind of the same problem, isn't it? Alright, so let me grab that for comparison, and you're going to be shocked. It's going to be the same. Okay, so we get an identical result, and that identical result comes from an equivalent system. Notice that I swapped some of the rows, so some of the equations were written in different orders, but we ended up with the same mesh currents. Okay, so another example of mesh analysis by inspection with a super loop in the problem. All right, same kind of plan. I promised you I'd label these. This is the KCL. I don't have room over here. This is the KCL for the super loop. This was the KVL for the super loop. And this was the KVL around I2. Okay? You can do it. You got to practice it, but I believe in you. All right, we're going to do one more like this because I think that's what we did last time and when I was introducing mesh. So I want to just be consistent, kind of work through all that. And then we're going to look at a couple problems that I don't use the shortcut on. And it'll be pretty obvious why I don't use the shortcut on them. Some people are smarter than me. Go figure. And they have clever ways of doing the shortcut, but I think it's a little more error prone. So we're headed there. Stay tuned. Good luck. Eventually. Here we go. Ready?